So this is a review skills chapter. All right, this is the pre-chapter to fractions. So last year, some of you did the pre-skills, or well, the skills that you should have learned in grade 6. Then I also gave you some adding and subtracting. We're going to be doing that again, and we're just going to keep going a little farther, so that by the time you're done, we've added, subtracted. We may throw in at the end of adding and subtracting is where you need to be at the end for grade 7. So we'll see how far we go past that. But these skills here that are in this booklet are all things that you should know by now, and we're just going to review them because sometimes we forget things, and it's been a little while since we've done the fractions. All right, so normally all of these have been done as separate lessons, and now I'm going to throw them all together as probably we'll do a little chunk of them, maybe all of them. I'm not sure how far we'll get, but we're going to do each of them. So each of these pages are designed with a little explanation at the top, and then they have some questions at the bottom. So they're not long and they're not difficult. Okay, can we not stomp our feet over there, please? So at the top, if you're not remembering what is going on, they give you a little explanation and they give you some examples. So we're just going to briefly go through those. Okay, so in order to do fractions, we like to know what our prime and composite numbers are. All right, prime numbers, right, have only 2 factors, 1 in itself, right? And for the most part, our primes that we use, they started them here 2, 3, 5, 7, right? 11, 13, you know, those sorts of numbers are our prime ones, all right? So those are our basic ones. If I want to make sure that I have that one, maybe I want to highlight them because those are the ones that most numbers break down to being anyways, are prime numbers. Composite numbers are the other numbers. So composite numbers have more than 2 factors, right? 1 and 4 and 2 and 2 and so on and so forth. So you can draw what's called factor trees for them, right? 45 is 5 times 9, and we circle our primes. Do we remember this? Yeah. Good. Well, hopefully it'll clue out for you. And you can notice that I can draw a couple different trees for 45 because there are different factors that make 45. 9 times 5 and 3 times 15, right? But the end result is 3, 3, and 5. 3, 3, and 5, right? 36, they chose 2 times 8. Well, right here, I can do another one because I can go 9 times 4, right? Neither of those numbers are prime, so I can go again. 3 times 3, oh, both are prime. 2 times 2, both are prime. So when I see that I end up with 2, 2, 3, and 3. So I would say 36 is equal to 2 times 2 times 3 times 3. 45 is equal to 3 times 3 times 5. And those are our prime numbers. Yes, please do that. They've provided you a line for them at the bottom. So they are giving you a tree to make and then a line to put the factors onto.
Oh, but my question was, do you want to write what you just wrote down?
Yes, please. Whatever I add in, please write it in. All right? I'll give you a moment. Yeah, just that back one's there. And so our goal is to get our tree to be prime. So our last little branches that are on our tree, our leaves on our trees, need to be the primes. All right? And then we always list them. It says list the factors from smallest to largest. Choose any 2 factors to begin. Stop when the factors are all prime numbers. All right? Just put your name on it and hold on to it. Put your name on it and take the next one.
Do you want us to do the stuff?
No. I'm going to give you some time afterwards. I'm going to go through a couple of the pages. Okay? Because some of you will take longer than others to do the pages. Okay?
So just write stuff down.
So just write the stuff I have at the top and you'll refer to it once I go on.
Would we get marked off for writing the factors not from small to largest?
No, but try to do that. It's just common. It's kind of like putting a capital on your name. Okay? That sort of thing. All right, are we good? Can I flip the page? All right.
Wait, what?
I'm going to flip the page. If you're done,
No, I'm not done.
oh, what's your question? Just give me a second here. So on 3.2, greatest common factor, is we're going to look at the factors. So I'm not concerned about the prime ones. I'm concerned about all the ways that I could get that number. All right? So for example, 32 is 1 times 32, 2 times 16, 4 times 8. And then they list them out. Now there's not a lot of space on these lines to do them, but I'm pretty sure the one that I wanted to do, let me just look at my book for a second here. Where's my binder? One of them I wanted to do as an example so that you have them. Yes, number 6. Let's do number 6 together. Okay? So you're going to make sure that when you run through your factors, really, you only have to run through 1 up to 9, right? And by then they start repeating themselves, right? So 1, I'm always going to have a 1 times 16, 1 times 12, right? 16, right, is 2 times 8. 16 has no 3's, right? 16 is also 4 times 4, right? 5 doesn't work, 6 doesn't work, 7 doesn't work, and I'm already back to 8, so I'm done.
Yeah, are you done once you get to
Yeah, you are done once you get to 4, because the other side was 4. But if you wanted to check. Okay, then I'm going to list, I'm going to just leave them like that for the moment, because I got to do the other one. 1 and 12, right? 2 and 6. This is going to test your multiplication skills, right? 3 and 4, and then I'm done, right? Because the other one was already 4. Okay, 5 doesn't work. We've already got 6. 7 doesn't work. Now, in the middle common, they want the common factors. So I'm going to go back and I'm going to circle what's the same in both of them. 1 is common. 2 is common. And 4 is common. You just have to circle one of the 4's. And I have nothing else that's common. And then in the last one, I'm going to say which one was my largest one? 4. Because the largest one is going to become important later on in math. Knowing what is the largest number that I can divide a number by becomes really important later. So this is kind of a skill that gets used later. So we write out our factors there. We write the ones that are common in the center one. And we write the greatest common factor in that one.
What about number 8? There's only 1 for each.
So that's what you do. That's just 1, right? 1 can be a common factor, right? The greatest common factor just means that they don't have anything in common other than 1. So it doesn't really help you anything, right? 1 will not reduce a number by anything. It's still that number. But there's lots of numbers where there's nothing common between them. It's just been 1. Okay? 3.3, reducing fractions. Okay? So they're going to show you one way, and I'm going to show you the other way that I would have also taught you, right? So 16 and 24, all right? If you are good at your multiplication table, you might recognize that there is a common 8 between 16 and 24, and you could divide out the 8 right off the bat, right? 16 divided by 8 gives me 2. 24 divides by 8 to give me 3. The thing that needs to be when we're reducing is that I remove the same number in the top as I do in the bottom, right? Same numerator and the same number gets divided. I didn't divide the top by 8 and the bottom by 5, right? Has to be the same. Now, there is other ways that you could do it, right? What happens if I didn't see that 8 was the biggest thing? I know that it's even, right? So I could half each of them right off the bat. Half of 16 is 8. Half of 24 is 12, right? May take me a couple extra steps to get there, but will I get there? Yes.
Yeah.
Oh, I'm still even. I can half them again, right? I'm going to half, right? Giving me 4 out of 6. Oh, I can half again. 2 out of 3. Now that is the long way of getting there, but there's nothing wrong with that, right? Okay. Another way of doing it, I'm going to do the exact same one. Let's do it up here. 16 over 20. Oh, let's go to above. Giving me some space. Here, I'll let you do that first. And it works with dividing by 3s, too. If you notice that something is divisible by 3, divide it each top and bottom by 3. Oh, maybe it'll half after that. Who knows, right? Let's look at that 16 over 24. Here's another way of doing it, okay? Take your biggest one, okay, 24. And think of some numbers that multiply to 24, right? 6 times 4 gives me 24. Could I use 6 or 4 to give me a 16? Yes, I can, right? 6 doesn't work, but 4 works. Could I write 16 as 4 times 4? Yes, I could. And then I just cancel out my 4s. And I'm left now down to a 4 over 6. But I recognize they're even, so I can half it to 2 to 3. Right? All right. So that is one way of doing it. That is the ones where they are, where you just have a numerator and a denominator. Numerator and a denominator. Now, when you have a mixed number like this, let's say we go back to their example here, we have 2 and 8/10. We do not have to worry about the 2. We leave the 2. It's got 2 holes. It's just the way it is. We only have to look at our fraction then, right? And again, 8 over 10, I could half it to 4 over 5, so that it becomes 2 4/5, right? Or I could do it as 8 over 10 is 5 times 2 and 4 times 2. So there's my 4/5. However, the way you like to do it, by now you should probably have picked up a method that you kind of like, right? Or you could use the idea, oh, I could divide top and bottom both by 2, right? However method you want to use it, okay? I've shown you 3 different kinds of ways to reduce. By now, pick one, or maybe the combination. I like to do the halving thing. I also like to write out my factors, right? Takes my brain out of trying to. This way, then you're not making a mistake of dividing one by 4 and the other one maybe by 6. I don't know. Sometimes that mistake happens, all right? So that is that page, all right? And I'm going to do 3, 4, and 3, 5, which are the opposites of each other. And then I'll let you work. No, I'm going to do 3, 4, and then I'll let you go back and do it. Finish it up today. Okay? 3, 4 has you getting a common denominator. So now, what it means is, how could I change my denominators so that they were exactly the same? And this is where your least common multiples come in play. I would have made you go through in grade 6 and go 4, 8, 12, 16, 20, 24. Ladies, you have to be quiet, okay? And those are really just your multiplication table, right? You can look at your multiplication table for 4 and 5, and then it asks you, where does the same number appear the first time? When does a matching number appear, right? And if I wrote them out, I will notice that the first time in my multiples where 4 and 5 match up together is 20. Okay? Now, you can get that number easily by going 4 times 5, taking your 2 numbers and multiplying them together. Now, that only works if there's not something that's already in common between them. Okay? So for example, let's say that I have 6 and, sorry, I don't need another line, 6 and 8. Okay? Now if I go along on 6 and 8 and I use that method of multiplying them together, right? And I go 6 times 8, I get 48. Now, 6 times 8 giving me 48. 48 is a really large number. The odds are is it probably had a matching one before 48, right? So what I like to do is I like to look at the two numbers and decide, is there a number that's already in 6 and 8 that's common between them? Corey Joe.
24.
No, I just want to look at 6 and 8 itself. Is there a number that is what makes up 6 and makes up 8 that are the same? 2, right? 3 times 2 gave me 6, and 4 times 2 gave me that. So that means they're already a common 2. So really, I could divide this by 2 and get 24, right? I can reduce it down. Now, is 24 a number that could be, that 6 and 8 go into? Yes. 6 times 4 gives me 24. 8 times 3 gives me 24. If I went all the way and I halved it again down to 12, would 12 even, could I even go far as 12? 6 goes into 12, but what's the problem with 8?
8 doesn't.
8 doesn't. So I can't go that far. So I know that my common denominator, right, is 24. Now, what do I do with these numbers once I find them? Okay, so what they're going to ask you to do is get a fraction with those denominators. All right, so for example, they had here, okay, let's say that I had, these were my two denominators. Let's say I had 1/6 and 3/8. Okay? So we decided that our common denominator, I could get them both to be 24. Does everybody understand that? Yeah, so far? Now I'm going to write each of those as 24s. So how did I get 6 to become 24? I times it by 4. But what I do to my denominator, I have to do to my numerator. So 1/6 became 4/24. Are they exactly the same fraction? Yeah, just one is more pieces to it, right? How did I get my 8 to become a 24? I times by 3. What I do to the denominator, I must do to the numerator. So I get 9/24. Cohen, I don't need. Okay? And that is what they're going to ask you to do. Let's do one more. Shall we do a hard one? Now I'm going to do the very last one. Okay? Did we finish writing that down?
Is that 1/9 and 2/3?
Yep. So that's these two. I'm going to do the very last one. All right? Because sometimes, so I'm going to start with the idea that I could multiply 9 and 3 together and 27, right? I multiply 9 and 3 together, I get 27. But is 27 the actual lowest one?
No, 9 would be.
Why?
Because 3 goes into 9.
Yes. Sometimes one of them only gets changed and the other one doesn't need to be changed. Right? Why am I going to go up to 27 when that's not the lowest one, because I always want the lowest one, when I could make 3 become a 9? So that's what you always check first. Okay? We're going to do check to see if your common denominator is one of your denominators. That is what you're going to do first. If your common denominator, what you're going to make both of them become, is already there. One of them is already in that form. So why change it? right? I don't need to go up to 27, which would be a denominator and a common denominator, but it's not the lowest one, right? And if we don't pick our lowest one, when we start adding and subtracting, multiplying, dividing, questions can become really large. I don't want to add a fraction with a denominator of 27 when I could add a denominator with 9. All right? So that means that if I want to make them both out of 9, this guy, did I have to change him at all? Nope. I can just write him down the way he is. But did I get the 3 to become the 9? I times by 3. What I do to the denominator, I must do to the numerator. And I end up with 1 and 9 and 6 over 9.
Is that a comma in between?
Sorry? Yeah, I put a comma in between. All right? So like 8 and 12. 8 times 12 is what? 96? There is definitely going to be a number that's less than 96. All right?
Yeah.
That you're going to figure out. Do not use 96.
44.
Okay? Yeah. Double your biggest one. Sometimes doubling your biggest one might give it. Because what's the first number that you could do to a number? Times it by 2, right? If I double it, will the other one go into it? Yep. 24.
Oh,
Yeah, 48's another one, but that's 48's a little bigger. 24 works there. All right. So you are stopping right there because then it goes on to another couple of things. So 3, 4, common denominator, reducing some fractions for me, greatest common factor, and priming composites. You have about a little less than half an hour. Some of you might be able to get it done today. Okay, some of you won't. Yes, just go to the end of there. Once you are done, stop. Okay? So once you get to the question that we just did, 1 over 9, 6 over 9, stop. All right? That is your job.